Welcome to TechNauts, a podcast by Envito, where we explore how innovation really works in practice. This episode is all about digital transformation in manufacturing, moving from spreadsheets and manual tasks to IoT, automation, and artificial intelligence. Production 4.0 promises a revolution: AI, IoT, digital twins, predictive analytics. Yet in many factories, the reality looks different. Data still lives in Excel files, systems remain unintegrated, and decisions are based on gut feeling. A lot of companies are still operating between the analog and digital worlds. So, how do you make digital transformation lead to better decisions, greater efficiency, and lower operational costs? In this episode, we'll show you how to take a step by step approach to manufacturing digitalization, from Excel to AI, so that each stage delivers real benefits rather than simply multiplying tools. We'll suggest where to start, which solutions to implement, and how to measure their business value. Let's get started. Digital transformation is accelerating, but is it delivering results? According to Gartner, up to 80% of manufacturing CEOs are increasing their investments in new technologies like AI, IoT, and data analytics to meet economic challenges and accelerate growth. Despite economic uncertainty, 85% of companies are maintaining or even expanding budgets for Industry 4.0 initiatives. On the other hand, statistics show that only 8% of digitalization projects in manufacturing are fully successful. The main reason isn't a lack of access to advanced digital technologies, but insufficient process preparation and weak organizational support. A lack of strategy and the misunderstanding that digitalization is a process, not a sudden revolution, often leads to wrong investments and confusion. A gradual, well planned introduction of new technologies reduces the risk of failure and allows companies to enter manufacturing digital transformation and Industry 4.0 with greater confidence. But before you get to AI, automation, or sensors, there's a more common challenge to tackle. How do you move beyond Excel in production processes? Many factories still rely on spreadsheets, paper reports, and scattered data sets. While Excel is considered a universal tool for production planning, downtime tracking, or quality monitoring, too many files and manually compiled reports quickly lead to information chaos and create data silos. According to research, 42% of manufacturing companies have not yet started digital transformation, and 70% of data generated by manufacturing operations is never used. Only 16% of manufacturing executives monitor production processes in real time. The rest rely on manually gathered data that becomes outdated almost immediately, making decisions difficult and adding unnecessary costs. Without a unified view of what's happening, many managers fail to see the full potential for improvement. The digital transformation in manufacturing Trends and Challenges study suggests that 2/3 of manufacturers admit they're lagging behind in digitalization, while market leaders who have embraced digital solutions are gaining a distinct competitive advantage. A Deloitte report notes that enterprises with higher digital maturity achieve stronger financial performance and better profit margins. The lack of a consistent approach to data and processes translates directly into losses. When manual reports and scattered data create more problems than they solve, the natural next step is to streamline existing resources and build a solid foundation for further digital transformation in manufacturing. But where do you even start when everything feels messy and disconnected? The first step in production digitization is to create a unified data foundation. While this may sound revolutionary, it's often more practical to focus on digitizing manufacturing processes and integrating what you already have, rather than replacing all your infrastructure at once. In many cases, you can simply link Excel spreadsheets to a database, integrate your existing ERP with production, or implement a manufacturing execution system module that automatically collects data from machines and production lines. Formulating a solid implementation strategy is crucial to ensure efficiency and security as you progress. At this stage, what really matters are a few key elements. First, centralizing data, bringing together information from ERP systems, Excel files, and warehouse tools into one shared database. Then there's electronic documentation, which means swapping out paper for tablets or other devices that send updates straight into the system in real time. And finally, basic monitoring, setting up dashboards to track things like line efficiency, downtime, or defect rates. Even if they're only updated once a day, they give a reliable view of what's actually happening on the floor. In practice, many companies use supervisory control and data acquisition tools, or middleware, to gather data from multiple sources into one place. This prevents endless copying between spreadsheets and enables a near real-time view of processes. For example, with our support, a Polish ultra-fresh food producer replaced scattered Excel spreadsheets with a single integrated production planning application. By automatically pulling data from the company database and providing a clear dashboard, multiple team members can now work simultaneously, without the risk of file conflicts or copy-paste errors. Even these initial digitization measures often have a tangible impact. It becomes much easier to identify the causes of downtime and fix them quickly, increasing efficiency and building trust within the team. The tools introduced at this stage provide a strong foundation for the next phases of manufacturing digital transformation, such as IoT, automation, or AI. If you're just getting started with production digitization and looking for a way to get your factory data in order, get in touch. At Envido, we help companies like yours organize processes and connect what already works into a cohesive system. You'll find more details in the episode description. All right, so what happens next on the path to digitization? Once your factory data is consolidated, the next move is to implement Internet of Things solutions that take digital transformation to the next level. These solutions collect real-time data from machines and automatically respond to specific events. Manufacturing companies are increasingly installing connected sensors on their machines. This enables faster response to changes, helps reduce downtime, and ultimately increases flexibility across the factory. Key elements of this stage include sensor technology and IIoT, adding sensors to machines to track things like temperature, vibration, or load, and connecting them to IoT platforms like Siemens MindSphere or Azure IoT. This way, data flows continuously to the cloud or a local server, giving operators a real-time view of what's happening on the shop floor. Then come advanced IoT platforms, like dashboards that show live production rates, cycle times, or overall performance. Think of Andon boards. They help managers and operators spot issues the moment something goes off track. And finally, there's reactive automation. This means setting up alerts and automated responses, like notifying maintenance when something's off, switching to a backup machine, or sending out AGV robots to deliver parts. It's all about staying flexible when things don't go as planned. Harley-Davidson, for example, used IoT at its York factory to continuously track production, reducing the full manufacturing cycle from 21 days to just 6 hours. A new motorcycle now rolls off the line every 89 seconds, a pace unimaginable without synchronized data flows and automated processes. At this stage, manufacturers often try out pilot automation solutions on smaller parts of the plant, perhaps predictive maintenance on a single line or the automation of a production cell with a collaborative robot. This allows you to test the technology on a small scale, refine it, and measure ROI before rolling it out across the factory, significantly reducing risk. The business benefits of IoT and initial automation are often realized relatively quickly. Companies report a reduction in unplanned downtime of up to 15%, with productivity gains of 10 to 20%. Sensors that track critical process parameters help reduce defects, while real-time data access enables rapid response and dynamic production adjustments. If you're at this stage and want better visibility into what's happening on the factory floor, or you're planning a pilot for automation, get in touch. You'll find more details in the episode description. And if you're already collecting data and have some processes automated, what's next? After collecting historical data from Stage 1 and real-time data from Stage 2, the next step in digital transformation in manufacturing is to apply advanced data analytics and artificial intelligence. At this point, it's no longer just about monitoring the production line in real time. Systems begin to predict future events and automatically optimize production processes. Now, a few things start coming into play. You've got predictive analytics, basically using large sets of data from machines or quality checks to spot patterns that aren't obvious at first glance. With the right algorithms trained on past data, you can start predicting equipment failures or demand shifts before they happen. Then there's AI in maintenance. These systems look at sensor data and flag potential issues before anything actually breaks. According to McKinsey, this can cut maintenance costs by up to 30% and reduce downtime by half. Next is automated decision-making. Machine learning algorithms step in to help with things like production planning, inventory management, or adjusting machine settings on the fly, all based on current data. Computer vision also shows up here. Think of cameras on the line using AI to catch defects in real time. And the cool part? That data gets looped back into the system to help figure out the root cause. And finally, robotics and autonomous vehicles, AGVs, drones, palletizing robots, all talking to the central system and adjusting their tasks based on what's actually happening in production. At this stage, the factory begins to resemble a nervous system, with information flowing seamlessly and a central brain constantly improving the performance of the entire organization. From a business perspective, this means increased productivity, streamlined processes, and reduced waste. In addition, implementing digital twins allows you to test changes in a virtual environment, reducing the risk of disruption to live production. Properly implemented, AI takes care of the routine number crunching, allowing operators to focus on problem solving and process optimization. According to industry surveys, 61% of manufacturers see AI as key to development by 2029, up from 41% in 2024, while digitizing factories can reduce production costs by 15 to 30%. In some cases, it can even double production efficiency. If the earlier stages are handled superficially, the system's predictions may be inaccurate. If the data foundation is solid, AI can deliver huge benefits, from reducing downtime to more accurate production planning. If you're looking for a practical way to use AI in production, we can help. Check the episode description and book a free consultation. Okay, so we've covered 3 key stages of production digitization, from organizing data through automation and IoT to implementing AI. Each stage presents exciting opportunities, but also specific challenges. Being aware of these obstacles early on allows you to prepare and greatly increases your chances of success. Simply replacing people with robots or implementing technology without considering existing processes often leads to disruption and expensive rework. Technology alone isn't enough. You need to consider workforce needs, real business conditions, and long-term management buy-in. Successful companies balance technology and people, build internal capabilities incrementally, and engage top-level leadership. Sometimes the hardest part is shifting mindsets and changing the way people work. Some employees may worry that automation or AI will inevitably lead to job cuts. Without their acceptance, even the best planned transformation can stall. That's why it's wise to launch a change management program right away. Engage the team, provide digital training, and communicate clearly that new technology supports people, not replaces them. Early success with pilots will also help build trust by demonstrating real benefits in practice. You might also run into a lack of skills or just not enough hands on deck. Data scientists, or IoT engineers, are still relatively new roles in many factories. An incremental approach, building internal skills over time, and working with external consultants can work well, provided the management team allocates the right budget and sets clear priorities. Departments don't always pull in the same direction, and that also may slow things down. Transformation often spans production, maintenance, IT, and finance departments, each with its own objectives. Studies by Zebra Technologies show that a lack of collaboration between IT and operations occurs in one-third of companies, seriously hindering progress. A cross-departmental project team with a shared vision makes decision-making much easier and increases the likelihood of success. Connecting machines brings great potential, but it also opens the door to cybersecurity risks. Once devices go online, there's a real need to protect them from hacking or unauthorized access. That means securing the OT network, using things like segmentation, encryption, and regular staff training. There are established frameworks that help guide best practices. And then there's the reality of older machines and legacy systems that just weren't built for this. Many machines, such as decades old PLCs, do not have interfaces compatible with modern standards. Companies often use technology bridges, such as IoT sensors attached to legacy equipment. Older software systems may require data migration to more modern platforms. If outdated hardware is hindering transformation, it may be time to consider replacing it. Leadership often feels the pressure to deliver fast results, but ROI isn't always immediate. Iterative steps with clearly defined benefits, a solid business case at each stage allow management to track progress and base further decisions on solid data. And that brings us to another key question on the path to digitizing a factory. How do you measure its effectiveness and minimize risk? To assess whether digital initiatives are delivering the desired benefits, define key performance indicators from the outset and systematically track your return on investment at each stage of the transformation. Measurable indicators make it easier to assess the profitability of projects, adjust operations, and motivate teams to seek continuous improvement. Research shows that digital solutions for manufacturing are essential to stay competitive. So, what exactly should you be measuring? Some example KPI include overall equipment effectiveness. It tells you how efficiently your machines are running. The higher the OEE, the fewer stoppages, the faster the cycles, and the less waste. Even basic digital tools help spot where things slow down. Then there's MTBF and MTTR, mean time between failures and mean time to repair. Predictive maintenance helps stretch the time between breakdowns and makes repairs quicker. Production throughput is another one, like how many units you produce per hour or how long the full cycle takes. Automating processes can sometimes double that output. Inventory levels and turnover also matter. With AI-driven forecasting, you can lower how much stock you need to hold and keep your supply chain more agile. Quality and scrap rates tell you a lot too. Metrics like FPY, first pass yield, or defects per million parts help you track where quality drops off. Digital analytics can catch those issues early and cut the cost of poor quality by a big margin. Then there's order lead time, from the moment an order comes in to when it ships out. If you can streamline how information moves, delivery speeds up. Harley-Davidson is a pretty extreme case, but even cutting lead time by 20% makes a difference. And finally, team engagement and productivity. That's something you can measure through things like satisfaction surveys or turnover rates. When people have access to the right info, like clear dashboards, it helps them do their job better. Highly engaged teams actually see 41% less absenteeism and 59% lower turnover. When calculating ROI, it's best to focus on specific projects, such as rolling out an and-on system, adopting AI for predictive maintenance, or implementing an IoT platform. Estimate the costs and potential benefits before you start, then review these figures once the solution is live. For example, an investment of £100,000 in predictive maintenance could save £140,000 a year by avoiding unplanned downtime, giving an annual return of 40%. Similarly, a £60,000 IoT platform that reduces scrap by 5% at scale could quickly pay for itself. There are also soft benefits, such as increased flexibility, a stronger corporate image, or even the opening up of new business models. Comparing before and after, baseline versus actual, and monitoring trends supports a process of continuous improvement. If certain metrics don't improve as hoped, investigate the root causes. Perhaps the bottlenecks are procedural or due to a lack of employee engagement. Transformation is an iterative cycle, and data provides the insights needed to adapt. Publicizing success, for example, by displaying key KPIs on a screen in the factory, boosts team motivation. When employees see a reduction in defects or downtime, they're more open to future change, which helps drive further development and improvement. As you can see, manufacturing digitalization isn't just about technology. It's a process, and the most effective way to go through it is in stages. Start with data integration and basic monitoring, move into IoT and early automation, and then explore more advanced AI solutions. Case studies from a range of organizations show that this incremental model minimizes risk and delivers measurable returns at each stage. Teams have more time to adapt, and production continues smoothly without major disruptions. Whether you're starting with a small pilot or taking your current digital transformation further, an iterative approach reduces risk and delivers tangible results. If you'd like to explore how digitalization could work in your factory, book a free consultation. We'll take a close look at your factory's unique setup and help find practical solutions so you can get real benefits from data-driven manufacturing, automation, and AI. You'll find the link in the episode description. That's it for today. We hope this helped you get a clearer picture of how digital transformation can work, step by step. Thanks for listening. Until next time.